Hello everyone, so this is our group project for the Mechanism Sessional Lab ME29002 and this is our team Himanshu Sharma 21ME30030, Priyanshu Singh 21ME30081 and Alok Kumar Roy 21MF3IM22. Our group has done the synthesis and simulation of Windshield Wiper Mechanism without any quick return effect. For the dimension synthesis of this mechanism, we have taken same dimensions from the question 6 of tutorial 2 and this is the sketch of that mechanism. But this has a quick return effect as can be seen in this motion. This mechanism has a quick return effect. So what we have done is that we used this part of the mechanism, but we have changed this driving part of the mechanism so that quick return ratio is not present. To synthesize that mechanism, this part of the mechanism, we need two positions of the rocker, which will be the extreme positions, so that we have taken the extreme positions of this rocker of this given mechanism. This one, this position and this position. This length, this distance between this point is in first case 170, which is something like this, and in the other case it is 230, which is nothing but depending upon these two lengths 230. So the difference of these two and one's the sum of these two, and that is over here. These were the two configurations that we have taken into another sketch, and then the position of the second hinge should be such that it lies on the line joining these 2 points. It should be such that the time taken for the rocker to go from this point to this point and back from this point to this point should be same. That second hinge should lie on this line joining between these 2 points. That mechanism is here. We have chosen that fixed hinge to be at a distance of 150 millimeters from this second hinge. It can be anywhere, but we have chosen this 150 millimeters. This fixes two lengths 80 millimeters and 150 mm of this 4-bar mechanism, which should be crank rocker mechanism, so that it can be driven by a continuous motor at this particular length. Next, we have chosen this length to be 30 and 120. It should be such that it's a Grashof crank rocker mechanism. Here it can be seen that 150 plus 30 is indeed less than 120 plus 80, and also this length is smallest of all, so it's a crank rocker.
Hi everyone, my name is Himanshu. For the simulation of the windshield wiper mechanism, I have used SolidWorks. So to create the mechanism, we have to first create individual parts, or we can say links. So to create an individual link, we have to first make a sketch of it. And the easiest way would be to use this slot like this and give it a appropriate dimension that we have synthesized earlier. Maybe 10 inches. And then extrude it. The height of extrusion doesn't really matter, but it's good to have equal extrusion in all the parts so that there is consistency while we assemble them. Then we need to make some holes in so that we can assemble them, which will act as hinges. Like this. After making this sketch, we need to extrude it. through all both so that it cuts on both the sides like this. So this completes one part. Likewise, we have to create all the parts. For example, this one is the ground. This length is 150 mm. This length is 150 mm. This angle is also coming from that dimensional synthesis which we have done earlier. To create this ground link, I have to first create this slot, this one, and then this one, and then define the correct angle based on the dimension that we have done earlier. And these radius, these are not really important for the working of the mechanism. And then the required holes that we have to make for the hinges. After creating all the links in individual files, we need to make an assembly and then insert all those individual components like this into that file. So this will be our ground. Then insert more components as in required, like this one. Now to connect them or to constrain them, first make sure that this component is fixed. So this component is fixed and this component is floating. So really the ground should be fixed. So this one is the ground and should be fixed, and others can move. So we need to constrain this part so that this part moves with respect to this part in a defined manner. So that is called mate. Here we have hinge mate. For the definition of hinge mate, we need to select two concentric selections, and which means that the faces or the features will be concentric. So say this one and this one are concentric, and two coincident faces which can be this and this. So this creates the hinge that we require, and through this option we can manipulate the direction in which we want it to be attached, like this. So physically it will be acting like as a revolute pair, as we have studied in the course. So with respect to the ground, it would have only 1 degree of freedom. Likewise, we have to insert all the individual components and assemble them. This is how it would look like if we assemble them. I have made some changes like this one. So what I have done is, this link can slide into this link. So basically this link and this link, this link and this link are connected by a prismatic pair, which can be actuated so that the area of wiping can be changed. And this link has been added so that this one and this one can be maintained parallel. And this part is just to basically mimic a glass wall. And if I just move this link, it can be seen that this works in the way we want without having any quick rhythm. If I can move it at a constant speed, but I have done that with a motor of constant speed, so we will see that. I have also done study by varying this length, so that we can see how the area of wiping changes as we change this length. Finally, for the simulation, I have attached a continuously rotating motor with a constant angular velocity to this link, this one, which is a crank for this crank rocker mechanism. I mean the 4R mechanism. This has a RPM of 25, and for the simulation, this is how it looks like. This is the path that this wiper is tracing over this screen. And to get the individual velocities, accelerations, you just have to select this, choose the part that we want to calculate for, like this wiper, then choose from categories, like we want to say plot the linear velocity of this wiper, the x component of it, then this is how it looks like over the period, over 5 seconds that I have simulated for. It has a time period of 2.4 seconds, as can be seen. After every 2.4 seconds it will repeat. I have already done the plotting of all the required things, like this x component velocity, y component velocity, magnitude of it, but it is very clumsy to look at all this data in SolidWorks. So what I have done is I have exported this data as CSV file and then plotted that using MATLAB so that we can see it better.
To generate the plot from the CSV file, we will need to import the CSV file into our MATLAB code. So I have done for all the parameters. Let me show you how it can be done. So first of all, we will open the CSV file and let me show you it. This is this CSV file for velocity in x direction with respect to time. We will generate a script for it. So the script has been generated, and for further plotting it, we need to write extra lines of code. I have already done it for various parameters like velocity, acceleration in tangential and radial direction, velocity of rocker, and the trace of the wiper, which will help us in visualizing the mechanism. So after generating the scripts of each of the CSV file, I've written down the MATLAB code for plotting the graphs of the physical quantities, which will help us in visualizing the mechanism in a better way. So first of all, we will see the plot of the trajectory of the wiper, which it follows during its wiping mechanism. Let me show it to you. So this is the trajectory of the wiper which it follows during its wiping mechanism. As you can see, if we increase the length of the prismatic link, the wiping area increases. So the red plot is for 300 mm, the green plot is for 310 mm link length, and the purple plot is for 330 mm link length. Moving on to next, let me show you the plot of the angular velocity of the rocker with respect to time. So this is the plot of the angular velocity of the rocker with respect to time. The time between these subsequently 4 marked points is approximately equal to t by 2, which is 1.2 second, and this proves that this mechanism is indeed a quick return mechanism, as it takes equal time to move back and forth from each of its extreme position. To next, we will see the plots of the velocity of the wiper. So this is the plot of the velocity of the wiper versus time. So the first plot is for the magnitude of the linear velocity of the wiper versus time, and subsequent plots are for its component versus time. Moving on to next, we will see the plots of the acceleration of the wiper versus time. So the red plot is for its magnitude, and the subsequent plots are of its component in normal and tangential direction. Moving on to next plot, this is the plot of the motor torque versus time, the torque which is required to run the windscreen mechanism. So this concludes our presentation. So it concludes the whole dimensional synthesis and its simulation of the windscreen mechanism without any quick return effect. Thank you.